Hi class, have you ever wondered why the height of your door is 6 feet and 8 inches tall? Alright, if you look around your house or if you go through a series of buildings, you'll notice that the door sizes are all about the same. And it's right around 6 feet, 8 inches. There's a reason for this, and we can use some statistics to show it. You see, when we look at the distribution of height between women and men, we can see that it's approximately normally distributed. Right? So for example, adult male's height on average is about 70 inches, about 5'10", with a standard deviation of 4 inches. We know that adult women have an average height that's a bit shorter. It's around 65 inches or 5'5", with a standard deviation of 3.5 inches. So we can take this information and use what we've learned in our most recent chapter on continuous distributions to actually find out how high we need to make a door so that 99% of the population can walk through the door without bending over. So I'm going to do that here. I'm going to come over here into my first square in Excel, and I'm going to go ahead and put in normal and then invert. And what this function does is that if I provide it with a probability, a mean, and a standard deviation, it's going to give me the value that's at that probability, all right? So I want to make sure that 99% of people, so 0.99, 99% of people can walk through the door. Since we can see that men are taller than women, we're going to use the males' descriptive statistics here. So we're going to put in 70 inches for males, and we're going to, as the mean, and we're going to put in 4 inches as the standard deviation. So I'm going to close that up, and now I'm going to hit return, and when I hit return, it's going to tell me the number of inches in height such that 99% of males are at that height or shorter. So in this case, that's going to be 79 inches. Now, you may not be able to convert that right away in your head, so you want to put this into a measure of feet, all right? So we know there are 12 inches in a foot. I can go ahead and say, let's take 8.1 and divide it through by 12. And I'm going to get 6.6. You still may not like that. You like the conversion of height and inches. So we're going to come over here. We're going to put height. I'll put feet over here. I'm going to put inches over here. Now we know that the value we found is in feet, so we're going to use the integer formula and just say pull off the closest integer for our feet, which is going to be 6 feet tall. And I want the remainder, but I want the remainder times 12 inches, right? So I'm going to have my 12 inches, taking the value we found, subtracting off the feet, and then hitting return. And when we do that, we find that the height necessary such that 99% of the population will fall underneath it is going to be about 6 feet and 7.3 inches. So at 6 feet and 8 inches, we're actually getting more than 99% of the population. And we're getting more than that amount. So you might say, well, what is that amount, right? Like how much of the population is actually falling in there? Well, that's when we can use our other formula. We can say, well, norm distribution, right? We're going to put in a value of x, which we know is going to be 6 feet 8 inches. So if it's 6 feet 8 inches, that's going to be 6 times 12 plus our 8 inches. We know we still have a mean of 70 inches. We know we still have a standard deviation of 4 inches. And we want this to be true because we want a cumulative distribution, so we put in true. And when we hit return, we're going to find that 99.4% of the population will be able to walk through a door without bending over. Hopefully you found this little video instructional and useful for your upcoming exam.